Hey, welcome back to Beard Squared. In this video, we're going to be problem solving using perpendicular lines. Coming up. Hey, so we're picking up from our previous video where we've done parts A and B, and in this video we're going to be covering parts C, D and E. So part C asks to find the lengths of the line segments AB, BP and AP given your answers in square root form. So to start off with, the line segment AB has a domain from -5 to 5, which is 10 units across. So therefore the line segment AB has a length of 10. So let's find the length of the line segment BP. Now if you look closely, we can draw a right angled triangle which has a rise of 4 units and it has a run of 2 units. We can work that out from the coordinate points that they've given us. From 0 to 4 is a rise of 4 units, and from 5 to 3 we have a run of 2 units. So we can use that to set up Pythagoras and to work out what the length of BP would be as the hypotenuse. If you're unfamiliar with using Pythagorean Theorem, then I would link a video in the cards above. Go and watch that, and then you can come back and finish this off. So therefore, if we label this A, B and C, we know that A is 2, B is 4 and C is the hypotenuse. So 2 squared plus 4 squared equals C squared. 4 plus 16 gives us 20. So the square root of 20 would give us C. So therefore, the line segment BP has a length of root 20. Now for the line segment AP, we can set up this right angle triangle APB. Now we already know that this is a right angle. This part here is a right angle because from part B, from our previous video, we proved that these two lines are perpendicular. So they intersect at 90 degrees. So at this point, you may want to go back and watch the previous video where we tackle part B. So we know that AB is equal to 10 and BP is the root of 20. So we can set up the Pythagoras equation, a squared plus the root of 20 squared plus 10 squared. Now if we rearrange this, we can move the root 20 squared on the right hand side. That would give us a squared is equal to 10 squared minus root 20 squared. That's equal to 100 minus 20, which is equal to the root of 80. So therefore the line segment AP has a length of root 80. Right, so let's move on to part D. Show that AP squared plus BP squared is equal to AB squared. So again, we've set up our right angle triangle and we label our vertices A, B and P. We're going to use Pythagoras' theorem, a squared plus b squared equals c squared. Since I need to show that this is the case, I'm going to label this A, B and C. Therefore, I know that A is equal to the length AP, B is equal to the length BP, and C is equal to the length AB. So AP squared plus BP squared equals to AB squared. Part E asks to explain the significance of the result in D. So why is this important? So for a semicircle with the diameter AB and point P on the circle, the triangle APB is right angled. So here's our diameter, and that's a point on the circumference. That's going to make a right angled triangle. That's actually one of the circle theorems that we'll cover in another video. And we know from part B as well that AP and BP are perpendicular, they intersect at right angles. As always, thank you for watching, and if you found the video helpful, drop me a like. And I'll see you in the next one.